This tutorial will introduce you to KISSA-1D and demonstrate how to define and simulate a simple EC reaction mechanism. The main window of KISSA-1D has a tool panel on the left-hand side which allows quick access to the main operations, which are also accessible through the main program menu. To start a new simulation, choose the File New Mechanism menu item or simply click the Mechanism Parameters button on the tool panel. A reaction mechanism can then be entered directly in the Mechanism and Parameters window using the standard chemical notation, where the reactants and products are separated by the equal sign. Once the reactions are entered, one must define species properties, their concentrations and diffusion coefficients. After that, reaction kinetics and thermodynamics need to be entered on the Reaction Parameters tab. We will leave the parameters of the electron transfer step as they are, and set non-zero values for the forward and reverse reaction rates of the homogeneous step. Note that instead of setting values for the forward and reverse rate constants, one can choose to define the forward rate constant and the equilibrium constant. To switch between these two modes, click Preferences button and choose the corresponding option on the Mechanism tab. Changing K equilibrium will now automatically change the value of the reverse rate constant. On the next tab of the Mechanism Parameters window, one can choose a potential waveform applied to the working electrode from cyclic and linear voltammetry, potential step excitation, and special CV forms. For the present example, we choose cyclic voltammetry and change the starting potential to plus 0.5 volt to scan in the direction of negative potentials, and also choose 2 CV cycles. The electrode type and size can be defined on the Geometry and Grid tab. Here we have a choice of planar, hemispherical or cylindrical geometry. Default simulation grid parameters that you see here can be used for any simulation without modification. These values are initial values used by the self-adaptive computational strategy implemented in KISSA-1D. The actual number of mesh steps in time and space will be automatically adjusted by the program depending on the reaction mechanism and rates of individual reaction steps throughout the simulation. All the parameters have now been set. Click OK to accept all the changes and Start Simulation button on the tool panel to run the simulation. Once the simulation is done, the computed current is displayed automatically. By default, the U-pack convention is used for plotting the current. This can be changed to the polarographic convention through Preferences. Simulated concentrations can be displayed by clicking the Concentration Plot button on the tool panel. Concentration distributions at any time moment can be viewed by dragging the time slider at the bottom of the window. This concludes the Quick Start tutorial. Watch other KISSA-1D tutorials for more details.